One of the reasons that people are interested in space is because it's part of the question, where did I come from? Everybody wants to know that. It's at the basis of all human philosophy.
I, for one, am fascinated by how we got here. What are these rocks that fall from space? What do they tell us? They tell us about other planets. They tell us about the origin of the solar system itself.
It's really important that visitors understand that they live in space. Yes, they're on Earth, but Earth is in space. And so this exhibit really is about exploring where we live.
So I study the universe because, first, it's cool. Second, it's enlightening. It's even intellectually empowering to walk out under the night sky and look up and say, I understand how the sun produces energy. I know what the future of our galaxy is. I know that there are planets out there that may harbor life.
It's always dangerous to try to predict what's going to happen 50 or 500 years in the future. And we don't know for sure where it is we're going to be going in space, what we'll be exploring. But we're reasonably sure that in just the next few years, space tourism will become a reality. In the next few decades, that we'll go back to the moon, to Mars, and visit at least one asteroid. We can be reasonably sure that after that, we'll go to the outer solar system, sometime at the end of this century or the next one. What will we do there? Why will we go exploring? What is the science that we're going to carry out? These are the things that we want to show you in the current space exhibition. About once a century, one of the most massive stars in our Milky Way blows up. It's a really unusual event. It's called a supernova, and since there are about 100 or even 200 billion stars in our Milky Way, it's really only very, very unusual stars, the most massive ones that do explode. What we're trying to do is find them before they blow up, build up a catalog of all the 7 or 8 or 10,000 stars, the most massive stars called Wolf-Rayet stars, that exist in our galaxy. Over this run, we've been honing our technique, and it's really not so much deciding which star is the most important one to look at, but which are the stars not to look at. That is, how to clean away the detritus and just pick out the few gems that are left there.
Oh,
a winner.
Winner.
I don't believe it.
I don't either.
It just popped out of nowhere. And our techniques are getting better and better. We're using more and more selection criteria, and so the fraction of winners is getting larger and larger.
People think of space, they think of astronomy, they think of astrophysics. That's about light and modeling light. What geologists do with space is we look at the rocks that come from space. My own research focus is on the chondrites. These rocks are the keys to the earliest solar system. They're like the leftovers of planet formation. What we do at the museum is we interpret their textures, their chemistry, and their isotopic compositions to see what are the temperatures, what are the heating mechanisms, what was the density of stuff in the disk of the planets before the planets formed and from which the planets formed. Why is the Earth habitable? What would be the conditions and the formation processes that would create habitable planets in other solar systems far away? So this is understanding the origins of the planet Earth, which is the foundation for understanding the origins of life itself.
Okay, I study planets orbiting other stars, and I think that this is very important to people in general for a number of reasons. If you have any interest in the origin of Earth itself, well, in order to understand that, we need to study planets in general. How do they form? How do they evolve? Do they die? These are questions that I think are very important to humanity. Yeah, this kind of work is somewhat unique in that I build my own scientific instruments to answer the questions that I want to ask. Most of the technologies we work on in there are centered around something called a coronagraph. A coronagraph is designed to create essentially an artificial eclipse inside a telescope so that if you look at a very bright star, you can see very faint things next to it. In the near environments of stars are their own solar systems, and we want to be able to see those and actually take spectra of them, measure what their chemical composition is, and all this sort of thing. So what we're trying to do here is develop the techniques to directly photograph exoplanets, planets orbiting other stars.
I don't think my story is unique. Growing up in New York City, a major metropolitan center, and you grow up in the city, you have no access to the night sky. except for a visit you might take to your local planetarium. For me, it was the Hayden Planetarium at age 9, and that was transformative to my life's ambitions. And it would take a couple of years, by the time I turned 11, when I realized you can actually study the universe professionally and even share the fruits of that research with the public, because the public clearly has an interest in the universe. It's why planetariums can exist at all. So from age 11 onward, if you're an adult who asked that perennially annoying question, what do you want to be when you grow up, of kids, my answer was an astrophysicist. The people who want to study Earth only and not think about other planets nearby do so at our collective peril. Lots to be learned by looking at neighboring planets. Venus, a runaway greenhouse effect. Mars, now bone dry, once had running water. The very existence of humans on this planet has led us to be turning knobs that will affect the future of our ecosystem, with consequences perhaps only learned by the study of other planets. What's important to empower our next 50 years in space is if people continued to dream about what our future might be. The last 50 years they certainly dreamed, and somehow they all stopped, for reasons I don't fully understand. If this exhibit will allow people to stoke an interest in what the future can bring by the fruits of space exploration, it will have succeeded.